Second part of study unit 3, we look at the last part of chapter 9 on point and interval estimation, so on page 269. In the previous section, we looked at confidence intervals for the population mean when we had large samples, meaning a sample size of greater than 30. So in this section, we are going to look at confidence intervals for the population mean when we are working with small samples, so sample size less than or equal to 30, and then also confidence intervals for the population proportion. And in this module, we only do confidence intervals for population proportion when we have large samples. Confidence interval for the population proportion is then given by this formula. So our lower limit will be the sample proportion minus the Z alpha over 2 value times the standard error of our sample proportion, and the upper limit will be the sample proportion plus the Z alpha over 2 values times the standard error of our sample proportion. Step 1, the confidence coefficient or the confidence level will be given to you. So again, you calculate confidence intervals at a 90%, 95% or 99% confidence level. Then in step 2, we determine the Z alpha over 2 value from our Z table, or if you know it off by heart, like in the previous section, you can just plug it in. Then for step 3, we calculate our sample proportion and the standard error if it's not given. And then for step 4, we can calculate and interpret our confidence interval for the population proportion. In example 9.6, they tell you the National Safety Council would like to estimate the proportion of vehicle accidents that are pedestrian related in a sample of 128 vehicle accidents in Johannesburg. So that means that our sample size N is 128, 30 involve pedestrians. So that is the number within that sample that meets the condition that we are investigating. So that will be X. And then calculate a 99% confidence interval for the proportion of all vehicle accidents in Johannesburg that are pedestrian related and interpret it. So for step 1, our confidence level is 99%, so 1 minus alpha will be 0.99. In step 2, that will make our Z alpha over 2 value 2.48. Then step 3, we calculate our sample proportion, which was 30 over 128, so that will give us a value of 0.234. And we also plug that in to calculate our standard error for our sample proportion. And then we have all the information to calculate our confidence interval, so we can plug that in to determine our 99% confidence interval for our population proportion. So our lower limit will be 0.137 and our upper limit will be 0.331. Then when you interpret confidence intervals for proportions, you do it in terms of percentages. So our interpretation in the context of the problem will be, we are 99% confident that the proportion of all vehicle accidents in Johannesburg that are pedestrian related will be between 13.7% and 33.1%. So you just express that lower limit as a percentage and the upper limit as a percentage. You can try exercises 4 and 12 on population proportion then, please. The confidence interval for population means when we have small samples, meaning sample size less than or equal to 30, will be given by this formula. So now we are working with T alpha over 2 values at a degrees of freedom of N minus 1 instead of Z, since we are working with small samples. So this comes from our T distribution in chapter 8. So our lower limit will be equal to the sample mean minus our T alpha over 2 value at N minus 1 degrees of freedom times the standard error of our sample mean, and then the upper limit will be our sample mean plus our T alpha over 2 value at n minus 1 degrees of freedom times our standard error for our sample mean. For calculating confidence intervals for the population mean when we have small samples is then as follows. For step 1, the confidence coefficient or the confidence level will again be specified as 90%, 95% or 99%. Then for step 2, you determine your t-value from your t-table, and you can't have fixed values that you can learn off by heart like in the previous section for the z values, because there's simply too many degrees of freedom. So you will have to look it up from the t-table. Then for step 3, we calculate our sample mean and our standard error for the sample mean if it's not given. And then for step 4, we calculate and interpret a confidence interval for the population mean. In example 9.7 on page 273, they tell you in a recent study a sample of 16 mine workers who were exposed to asbestos for a long period of time was studied in Australia. Then they give you the breathing efficiency for these 16 miners, and they ask you to calculate a 90% confidence interval for the population mean breathing efficiency of the population of miners and to interpret it. And then usually when we work with small samples, they will assume normality, they will specify that, but it refers to the population. So it doesn't mean that you are going to use your z-table. You are still working with small samples, so you will use your t-table. If we look at our data then, our sample size was 16, so that means that our degrees of freedom will be 15. Our sample mean and sample standard deviation were not given, so we will need to calculate that, and we want to determine a 95% confidence interval then. So our confidence level will be 1 minus alpha will be 0.9, and we want to look up our t-value at the degrees of freedom of 15 then. If you look at the area under your curve, our confidence level was 0.9. So since the area under our curve is 1, it means that 10% of the time our confidence intervals will not include our population mean. So since our area under our curve is symmetrical, it means it will be 5% below the lower limit and 5% above the upper limit, or then 0.05. But remember, the probabilities in the t-table is given to the left-hand side of a positive t-value, so that whole area will be included. So we will take 0.9 plus 0.05, so the probability that we will look up in our t-table will be 0.95, and we do that at the degrees of freedom of 15. So if you go to the top row in your t-table, we look for a probability value of 0.95, and we go to a degrees of freedom value of 15, so that means that our t-value will be 1.753. So we can write down our t-value for step 2. Then we calculate our sample mean and our sample standard deviation for step 3. The values in the textbook is incorrect, so you can correct them please. And then from there we can calculate our standard error. Then we have all the information to calculate our 90% confidence interval for our population mean. So we can plug in our values, and our lower limit will then be 199.126, and our upper limit will be 222.324. So because the other values were incorrect, your lower limit and upper limit is also indicated incorrectly in your textbook, so you can correct them please. Then for the interpretation in the context of the problem, you go back to what we wanted to determine a confidence interval for, and you interpret that in terms of the percentage. So we are 90% confident that the population mean breathing efficiency After population of minus will be between 199.126 and your upper limit of 220.324. Then you can try exercise 3 for me, please.